So to answer these questions, you can annotate on the screen. You can also use your chat or the mic. The first one, different gases diffuse at different speeds. What is meant by the term diffusion? How we define the term diffusion? So it's a movement of molecules from a region of a high concentration to a region of low concentration. Movement of molecules or movement of the particles, that's right. What property of a gas molecule affect the speed at which it diffused? Because the speed of diffusion depends on the mass, molecular mass or relative molecular mass, you can also say, or atomic mass, as well as the temperature, the speed. But molecular mass is appropriate here. In part B, helium is a gas which is used to fill balloons, and it is present in the air a very small quantity. Diffusion can be used to separate it from the air. Air at 1000 degrees centigrade, so like example, we have a mixture air 1000 degrees centigrade, is one side of a porous barrier. So porous barrier means like small openings are there. That is a porous barrier. And the air which passes through the barrier has a large amount of helium. Air contains a very small quantity of helium. So what they're saying, other side of this porous barrier, most of the helium is present. Why does the air on the other side contain more helium? What is the reason for that? What might be a reason why we have a greater amount of helium on the other side? So helium will be lighter and it will diffuse faster. Instead of mentioning the size of molecule, better use the term mass. Because when you refer the size of molecule, scientifically it does not make sense. The mass is the quantity which should be used. So you should mention that helium diffuse faster because it is lighter. What is the advantage to have a air at a high temperature? Because one side the barrier is present. If it was if it was a porous all around, like example, if the question in we were having a barrier all around, then every side we will have a helium. But there's a barrier is there, so a porous barrier, like one side opening is there. That's why one side helium will diffuse. The diffusion occur more quickly. That's right. As a part at high temperature, particle move faster.
Change for oxygen.
Yes, there is, because here is an element. What is the oxidation number in element? You have to check.
No.
Elements oxidation numbers are zero.
Zero.
Yeah, every element oxidation number is zero. Most helium is obtained from a natural gas which is found in US. Natural gases contain a methane and 7% of helium. One possible way to obtain helium would be burn the methane. Write a complete equation for combustion of a methane. So complete combustion means it should give carbon dioxide. So we will have methane, which is CH4 plus O2. When it be burned completely, a complete combustion will give carbon dioxide plus water. For a combustion equation, whenever you want to balance a combustion equation, you start with carbon, followed by hydrogen, and then oxygen. So we start with carbon. So we start with carbon. We have one carbon. The carbon is balanced. Hydrogen 4. So we want to make 4. We put 2. Hydrogen is also balanced. What about oxygen? Oxygen, we have 2 here and 2, 4. So we want to make 4 oxygen. So we put 2. Oxygen is also balanced. So for a combustion equation, start with carbon, followed by hydrogen, and at the last, oxygen. Suggest why this would not be a suitable method of obtaining helium. Like, as you can see, a methane is there and helium, and that contains 70% of helium. So why this is not a suitable technique? Because what will happen, uh, you don't have to refers to the environmental effect, you can refers to the subs, like example, first methane and helium, the mixture was containing methane and helium. But when you burn the methane, now the mixture will have carbon dioxide, mixture will have water vapor, and the mixture will have helium. Now more substances are there in a mixture. As a result, it will not be suitable. So suggest why this would not be a suitable method of obtaining helium. So reason is that the combustion of methane produce more products. So it will make it much more difficult to extract helium from like a large mixture as compared to a small mixture. First, it was only a mixture of methane and helium, but now it's a mixture of carbon dioxide, water, and helium. So we have to separate now helium from two more substances. Before it was only one substance. So the right answer for this, that combustion of the methane produce carbon dioxide and water. So it will become difficult, or it will be difficult to separate three substances from each other as compared to two substances. Suggest another method other than diffusion by which a helium could be separated from a natural gas. How one method is that's good. The fractional distillation is a method which can be used to separate the gas. But when we do a fractional distillation, first the gas is converted into liquid, which we call condensation, and then we allow the we allow the liquid to separate on the basis of the boiling point. So whenever you are separating the gas, you can use a method of diffusion, but practically fraction distillation is appropriate rather than diffusion. So this was a topic one. These are the topic one questions about the states of the matter.